So good morning everyone. Welcome to my YouTube channel Asymptotes. So today we are going to see fourth lecture on asymptotes of curve. Today we are going to study how to find asymptotes of a curve which is given in polar form. Okay. So first of all we should know what is polar form. So we know that this is x direction, is x direction, y direction and y dash direction. This is x axis, okay? X dash axis, y axis and y dash axis. So every point x, y in this plane can be identified by two things: this distance r and this angle theta. Okay, r is called radial distance. R is either 0. So what is the possibility for r? Either 0 or it is positive. Okay, and what is theta? What is theta? Theta is always varying. It can be at most 0. It can vary from 0 to at most 2 pi. Okay, 360. So every point in xy plane can be expressed as this. So if we join this line, so this is x distance and this is y distance. So this is x distance, this is y distance. So what is if we apply here trigonometry, what is cos theta? Cos theta is x upon r. So this implies x is equal to r cos theta. Sin theta is equal to y upon r. This implies y is equal to r sin theta. Okay. Okay. So I am writing what is the definition of polar form. So equation of the form r is equal to f theta. Okay. So r is radial distance greater than equal to 0 and theta varying from 0 to 2 pi or in some interval, lesser interval. X is equal to r cos theta and y is equal to r sin theta. Okay. Is called polar form of the curve. Okay. So we have x is given by r cos theta and y is given by r sin theta. So this is polar form. So how to calculate asymptotes of a curve given in polar form? Asymptotes of a curve given in polar form. Okay. So let R is equal to F theta be polar form of a curve. So X is given by X is equal to R cos theta. Okay. So how we can write this? What put the value of R theta, cos theta there. And Y is equal to given by R sin theta. That is F theta sin theta. So what we have actually? So we have X is equal to F theta cos theta. Y is equal to F theta sin theta. And where theta varies from I. I is interval. Interval. I is subset of 0 to 2 pi open interval. Okay. Zero to 2 pi open interval. Okay. So what is this now? So this is actually parametric form of the curve. This is parametric form of the curve. And we know how to calculate asymptotes of parametric form of the curve. We know now we can calculate the asymptotes of the curve in okay, asymptote of the curve discussed in lecture 3. Discussed in lecture 3 on asymptotes of curve. In lecture 3, we have discussed how to find asymptotes of a curve given in a parametric form, because our polar form converted into parametric form. Okay, so we know how to calculate. Now we can calculate by that process. Okay. So example we are taking. See this example. R is equal to 1 by theta. So 1 by theta means, so 1 by theta. So we have to calculate its asymptote. So what is F theta is? So this is R cos theta. R is here 1 by theta. This is cos theta. So what is this? R is equal to 1 upon theta. That is my F theta now. So X is equal to R sin theta So x is f theta cos theta. F theta is 1 upon theta, that is cos theta. That is cos theta upon theta. Okay. Now what is y? F theta sin theta, that is sin theta 1 upon theta, that is sin theta upon theta. Now, where can be problem for base to x and y? 0 is the only possibility where theta is equal to 0 is only possibility where asymptote may exist. Okay. So see that at this, you see that limit, this is my phi theta and this is my xi theta. So limit theta tends to 0, phi theta is equal to limit theta tends to 0, cos theta upon theta, that is plus minus infinity. Okay. And what is this? Limit theta tends to 0. So theta can be approached from right. Okay. We have right direction only. Because 0 to 2 pi it can be range of theta. And what is this? Sin theta upon theta? That is 1. So this implies y is equal to 1 is vertical asymptote for the curve. Okay. For the curve. So this is the only asymptote. Now we are taking another example. Question, or you can say example 2. To take this one. R is equal to 1 upon 1 minus cos theta. Okay. Usually we take the value of theta in between 0 to 2 pi for no repetition. But if we can rotate theta beyond this one, we will get the same values. But whenever some type of question comes, we will consider the theta throughout real line. Okay, throughout real line. Okay, so you see that what is x? So this is my f theta. R is equal to 1 upon 1 minus cos theta. So this is my f theta. So x is equal to r cos theta. So this is cos theta. F theta. Cos theta. 1 minus cos theta. And y is equal to f theta. Sin theta. What is this? Sin theta upon 1 minus cos theta. Where is the problem? In denominator, it is the problem. So, when denominator is 0, so theta, you can take as theta depending on 2 and pi plus minus 0. That is 2 and pi. Problem is at 2 and pi and belongs to natural number union 0. Sorry, n belongs to Z, you can say. So n belongs to Z. N belongs to Z. Okay. But, okay. N belongs to Z. You can take. But it is equivalent to saying that you can take, because theta is nothing but 0 to 2 pi. So we can always consider, so you can take Z, okay, no problem. So this is this. Now, what is the limit theta tends to theta n? Okay. So what is the phi theta here? Phi theta is nothing but, this is phi theta. This is xi theta. Okay. 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 So theta tends to theta n. What is this now? This is phi theta. What is the limit of this? Limit of theta tends to 2 and pi. And this is cos theta upon 1 minus cos theta. So this is plus minus infinity. Okay. Plus minus infinity. And what is limit? Theta tends to theta n psi theta limit theta tends to 2 and pi. Okay. Sin theta upon 1 minus cos theta. So this is 0 upon 0 form. 0 upon 0. Indeterminate. Net form. Undeterminate form. Okay. So we will differentiate and calculate its value. This is, you calculate, you differentiate limit theta tends to 2 and pi. This is cos theta upon sin theta. Now what is this then? Again this is plus minus infinity. So now both the limits are coming infinity. Both the limits. So this implies no horizontal as well as vertical asymptote exist. Only oblique asymptote may exist. So how to calculate oblique asymptote in this case? To calculate this limit, A is equal to limit theta tends to theta n. Because this limit is depending on n, I will write n here. Psi theta n, phi theta n. Limit theta tends to 2n pi. What is this? This is nothing but sin theta upon cos theta. So this is actually 0. This is actually 0. And what is Bn? Limit theta tends to theta n, that is phi theta phi psi theta n minus a n times phi theta n. So what is this limit? Limit theta tends to 2n pi. So this is theta n and this is 0. Limit theta tends to 2n pi. So this is actually theta here, not theta n. Okay. This is, we already checked that this is actually plus minus infinity. We already checked. So what does it mean? So limit of B does not exist. Does not exist. So this implies no oblique asymptote exists. For oblique asymptote, for a distance of oblique asymptote, it is necessary that A and B limits should exist. So no oblique asymptote exists. Hence, no asymptote exists for the given curve. Okay. Given curve. So today's question up to this, or today's lecture up to this, if you have any problem related to this, you can comment on my YouTube channel. Like, share, comment and subscribe my YouTube channel. So thank you very much for today's lecture. Thank you very much. We will see you in next lecture. Thank you very much.